function notation today. There's going to be several other things that we do. First, we're going to solve function notation when we're given an x value. And then we're going to solve function notation for when we're given the y value or the f of x value. We're also going to interpret some things that are already in function notation. So the first thing that I want to start off by saying is when I scroll down, we're going to evaluate these functions. A lot of people, when they see that f of x, they freak out, right? So one thing that I want to point out is truly both of these situations where we have slope-intercept form, we've already talked about this, y equals mx plus b. When we have a function notation, f of x equals mx plus b, we're going to treat them the exact same way. That means we're going to graph them the same, we're going to solve them the same, we're going to do pretty much everything the same. When we see f of x, just treat it as if it was y. Okay, so don't freak out, just pretend like it's y. Okay. When we look at this function, it says f of x equals negative 4x plus 7. So we need to evaluate this when x equals 2 and x equals a negative 2. So all we have to do is plug 2 in for x. So let's do this first one. F, we're going to plug 2 in for this x and 2 in for this x. Now, like I said from the beginning, we're just going to pretend like this is y. This does not change. This just tells us we plugged 2 in for x. That's what that says. So our answer is going to say, when we plugged 2 in for x, it equaled whatever this is going to be. Does that make sense? So, negative 4 times 8, or times 2 is a negative 8. Negative 8 plus 7, negative 1. So again, like I said, if this was y, it would just be y equals negative 1. Now, we just told ourselves, or whoever is going to be looking at your data, or your paper, or whoever, when I plugged 2 in for x in that equation, I got negative 1. Don't worry about this part. This part's just, it's designed, in my opinion, to kind of trick you a little bit. We got to use our critical thinking skills. Again, one more time. This says, when I plugged 2 in for x in this equation, I got negative 1. That's the only difference. It's just like y equals negative 1. So now we're going to do the negative 2. We're going to change colors. So we've already plugged 2 in. Let's take that off our list. Now we got to plug negative 2 in. So we have f of negative 2 equals negative 4 times a negative 2 plus 7. Okay, so like I said before, the only thing I did is I took that negative 2 and I plugged it in for this x and for this x. Now all we got to do is solve it. And again, we don't change this part. We bring it down. We are saying when I plug negative 2 in for x, this is what I got as my answer. That's all we're saying. So negative 4 times a negative 2. That's a positive 8. A positive 8 plus 7 is 15. So that is how we evaluate a function when there's two different x values. We solve two different equations. That's all we did. So when we plugged in a positive 2 into our equation, we got a negative 1. When we plugged in a negative 2 into our equation, we got 15. That's all there is to it. Go ahead and pause the video and try to solve this one. Okay. Now, all we have to do is the exact same thing that we just got done doing. We're evaluating this function, f of x equals x plus 6, and we're plugging these three numbers in for x. That's all we are doing. So we have the f of a negative 2, which equals a negative 2 plus 6. So negative 2 plus 6 is 4. So when I plug the negative 2 into this equation, I got 4. Okay, let's do a second one now. We're going to plug 0 in. For f of 0, when I plug 0 in for x, I got, well, 0 plus 6 is 6. So f of 0 equals 6. Okay, and now we'll do our third one. We're going to plug in 5. So we have f of 5 equals 5 plus 6. So when I plug 5 in for x, I got, what's 5 plus 6? 5 plus 6 is 11. So those are our three answers. And again, we're just treating these like y. We are just saying, when I plug negative 2 in for the function, I got 4. When I plug 5 in, I got 11. And when I plug 0 in, I got 6. That's all we are doing. Okay, let's move on. We're going to interpret function notation. Now, we've talked about interpret before. Interpret just means to explain what it says. That's all we are doing. We are writing down what these functions said. So we read the directions. Let f of t be the outside temperature in degrees Fahrenheit, t hours after 6 a.m. Explain the meaning of each statement. So we know what t means. T means hours after 6 a.m. And it said f of t, right? So that means the only possible spot for t to be is right here. That is t. That means that this value right here is going to be our degrees at that time. So this is 0 hours after 6 a.m. And if there's 0 hours after 6 a.m., the time is still 6 a.m., right? So all we have to say is at 6 a.m., it was 58 degrees Fahrenheit. Pretty simple, right? Okay, let's do the next one. This one says, "6 hours after 6 a.m., it was n degrees." So that's what we're going to say. We need to figure out what 6 hours after 6 a.m. is. It's okay to count on your fingers for this one. 6 a.m., 7 a.m., not, oh geez, I got to count. Yeah, 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10, 11, and noon. So 6 hours after 6 a.m., it is noon. So at noon, and you can still say 12 p.m. if you want. At noon, we don't know our temperature, so we say it was n degrees Fahrenheit. That's all we are saying. We are saying what we see. We're not given anything else but that, so that's what we got to say. Okay, this situation, it may be easier to figure out the times before we write it out. F of 3, that means 3 hours after 6 a.m. 6, 7, 8, 9. So at F of 3 is 9 a.m. At F of 9, well, at F of 6 it was noon, so 3 more hours is going to be 3 p.m. Okay, now we have to interpret what our inequality is telling us. So at 9 a.m., it looks like it was less than 3 p.m. So less in the form of temperature is colder, right? So this is telling us at 9 a.m. it was colder than it was at 3 p.m. So that's what we write. At 9 a.m. it was colder than at 3 p.m. Not too challenging, right? We are just reading what this says, and we are writing it down. Again, in this situation, t was the hours after 6 a.m., and our number was the degrees at that time. So, now we're going to do our monitoring progress, and we're going to move on. Okay, go ahead, pause the video, and we'll go over 2 and 3, and then we'll have another monitoring progress down here. Okay, so 4-2. I think I'm just going to tell you the answers, because hopefully you solved these on your own. If you solve them on your own, for f of 3 here, we should have gotten, looks like I have 1. Okay? For f of a negative 4, you should have got negative 13. And for f of 0, you should have got negative 5. So these are your 3 answers for number 2. And again, if we plug 3 in, 2 times 3 is 6, 6 minus 5 is 1. If we plug negative 4 in, 2 times negative 4 is a negative 8. Negative 8 minus 5 is a negative 13. And if we plug 0 in, 2 times 0 is 0. 0 minus 5 is a negative 5. That's where we get our 3 answers from. Okay, for number 3. Again, I'm assuming you solved it already, so I'm just going to give you the answers. For f of a negative 4, you should have gotten 3. Okay, for f of 0, you should have gotten negative 1. Ooh, I should change this f to a g. Now I'm changing this f to a g because originally we were given g of x, right? Okay, and g3 equals a negative 4. Now, the only thing that might be confusing is how I got 3 for g of a negative 4. So let's set it up. I'll just solve that one real quick. So I have g, and I put a negative 4 in. Equals, remember that negative stays with our variable, so negative and then a negative 4 minus 1. Now remember, when we have 2 negatives, we have divergent turns to a positive, so really this is 4 minus 1, and 4 minus 1 is 3. That's how we got 3. All right, make sure you got the right answers, and then we're going to move on. Okay, try this monitoring progress. Pause the video, and we'll go over it together. Okay, this is the same type of situation we had in example 2. Let f of t be the outside temperature, and t represents hours after 9 a.m. Explain the meaning of each statement. So, we know t represents hours after 9 a.m. And this is where t is going to be, right? And that's our temperature. So, 4 hours after 9 a.m., that's 10 a.m., 11 a.m., 12 a.m., 1 p.m. So at 1 p.m., it was 75 degrees Fahrenheit. Okay? At f of m, we don't know what time it is, so I'm okay with you saying at m, it was 70 degrees Fahrenheit. Because again, we don't know what the time is. M hours after 9 a.m. doesn't really tell us what the time is. Okay, here. It's going to be easier to write the time before we already assume what it says, right? So 2 hours after 9 a.m., that's 11 a.m. 9 hours after 9 a.m., what time is that going to be? Well, let's think about it. So 9, 10, 11, 12, 1, 2, 3, 4, 5, 6. So 6 p.m. Okay? So now this tells us at 11 a.m. it equaled at 6 p.m. So that means the temperature was the same at both 11 a.m. and 6 p.m. So we can say the temp was the same at both 11 a.m. and 6 p.m. Now we don't know what the temperature is, but we know that the temperature was the same. Okay, now we go here. 6 hours after 9 a.m. Well, 9, 10, 11, 12, 1, 2, 3. So this is 3 p.m. 0 hours after is still 9 a.m. So this tells us at 3 p.m. it was warmer than it was at 9 a.m. So at 3 p.m. I'm going to say hotter. At 3 p.m. it was hotter than at 9 a.m. All right, make sure you have the right answers written down. Make sure you understand why they are that way. And of course, if you have questions, go ahead and ask me in class. Okay, now we are solving for the independent variable. We've talked about this before. The independent variable is the same as the domain. The domain is the same as the input. So that means the independent variable is the input, which in this situation it's x. So we are solving for x. That means we have to get x by itself. Now another way to look at this is it tells us find the value of x, which is what we're finding, for which h of x is a negative 7. That means we are replacing the entire h of x with negative 7. So we are getting this out of here, and we are putting negative 7 in its place. So negative 7 equals 2/3 x minus 5. Now all we got to do is solve it like a normal linear equation. Add 5. Negative 7 plus 5 is a negative 2. We have negative 2 equals 2/3 x. Now I'm going to rewrite it up top so we can talk about what we're going to do next. We still have a negative 2 equals 2/3 x. And remember, you have two options here. You can either A, divide 2 by 2/3 in your calculator, or B, we can multiply by the reciprocal, and the reciprocal is the opposite of a fraction. So the opposite of 2/3 is 3/2. If we multiply by 3/2, we cancel out everything, and we have to multiply over here by 3/2. When you multiply by 3/2, we know that negative 2 is over 1. Negative 2 times 3 is a negative 6. 1 times 2 is 2. Negative 6/2 turns into a negative 3. So our final answer is x equals a negative 3. Okay, now move on to the next one. M of x equals 7. So we are taking this m of x out and we are putting 7 in its place. 7 equals 4x plus 15. We subtract 15. 7 minus 15 gives us a negative 8. And now we know that we have to divide by 4, which gives us x equals a negative 2. Okay, now we're going to solve the one on the right. We see immediately our k of x equals 15. That means we are knocking out our k of x. We are putting 15 in its place. 15 equals 6x minus 12. Again, we are just solving this like a normal linear equation. We add 12. We know 15 plus 12 is 27. Now we have to divide by 6. Now you can either divide 27 by 6 and get your answer, or you can reduce the fraction. So we have two possible answers. We have x equals, we got 4.5, or the reduced form of 27/6 is 9/2, because we can divide them both by 3. So I'll accept either of those answers, 4.5 or 9/2. Of course, like I said, if you have any questions, please ask me in class. Okay, we are going to move on to the monitoring progress 3. Okay, go ahead and pause the video, do the monitoring progress on your own, and then play it because we're going to go over it together. Okay, in this situation, we see that f of x equals 21. That means we are taking f of x out. We are putting 21 in its place. So we have 21 equals 6x plus 9. The way to solve this is we subtract 9. 21 minus 9 is 12. And now we have to divide by 6. So we have 2 equals x, or x equals 2. Now we move on to the next one. We are putting a negative 1 in g of x's place, so we take g of x out, put a negative 1 in, So negative 1 equals negative 1/2 x plus 2. First thing we have to do is subtract our 2. That gives us a negative 3 equals a negative 1/2 x. And again, this is a situation where you can either divide by 1/2 to both sides, or we can multiply by the reciprocal. When we are dividing by 1/2, we are technically multiplying it by 2 over 1, which is just 2, right? So we are multiplying this by a negative 2. A negative 3 times a negative 2 is a positive 6. So 6 equals x. Make sure you get those both right. If you do, you're ready to move on. It's the homework.